Am I audible to you?
Yes, sir.
Okay. Good morning to everyone. In the previous class, we have done the characteristics of DC motor. The first one is torque versus armature current characteristics, and second one is speed versus armature current characteristics. Now, tell me what is the torque equation? Tell me anyone. What is torque equation? Manish, Deepak, yes,
FIIS.
T is equal to K I I A. And what is the speed equation? N is equal to V minus IARA by K phi. Now today's topic is speed versus torque characteristics. Speed versus torque characteristics. First we do for shunt motor. For shunt motor. For shunt motor, what is the torque equation? For shunt motor, what is the torque equation? Manish, tell me. For a shunt motor, what is the torque equation? Tell me, Manish. Am I audible?
Yes, sir.
For a shunt motor, The torque equation is, Manish, tell me what is the torque equation for shunt motor? T is equal to
Sir, T is equals to K phi IA.
uh, T is equal to K phi Ia. This is a general torque equation for any kind of motor. But in case of shunt motor, we modify the torque equation after taking phi constant, and the torque equation becomes T is equal to K dash into Ia. For shunt motor, though the phi is constant. Why phi is constant for shunt motor? Tell me. We know that phi is proportional to I SH. Though the supply V is constant for normal case, so ISH is equal to V by RSH should be constant. Though the shunt current is constant, so we can say the phi is constant. So phi is constant. Though phi is constant, we can modify the torque equation such that T is equal to K dash into Ia. From this equation, what we get? Ia is equal to T by K dash. And what is the speed equation? N is equal to V minus IRA by K phi. This is the speed equation. And for shunt motor, we modify the torque equation such that N is equal to V minus IARA by suppose K1, because the phi is constant. So we modify the the speed equation like V minus IARA by K1, because the phi is constant. Though the phi is constant for shunt motor, we can write N is equal to V minus IRA by K1. K1 is another constant. From this equation, what we get? N is equal to V by K1 minus RA by K1 into IA. We can write that. We can write that. Khushbu,
Yes, sir.
we can write that N is equal to V by K1 minus RA by K1 into IA, like that. Can we write that? Yes or no?
Sir, it's K dash, no, sir.
What?
N equals to V minus IA RA by K dash.
K dashed. No, we
Yes,
are
sir.
taking another constant K1. You can write K dashed,
Increases
but we are
constant.
taking another constant K1. You can write also K dashed, because we are taking K into phi is equal to another constant K dash. You can write that. Here we are taking another constant K1. Now, if we replace the value of Ia in this equation, what will happen? We are replacing V by K1 minus RA by K1 into T by K dash. So what we finally get, n is equal to v, v by k1 minus Ra by k1 into T by k dash. Suppose this is V by k1 minus Ra by k2 into T. We can write like that. Can we write that? Manish,
Yes, sir.
now tell me what is the nature of that equation? Tell me the nature of the equation.
Increasing from V by K dash.
The equation is like y is equal to c minus mx. The nature of the curve is like y is equal to c minus mx. So what is the nature? If we draw the graph, suppose this is n and this is t. What is the nature? Tell me, Manish, Khushbu, Yash, anyone? What is the nature of that curve?
Sir, negative straight line.
Negative straight line. Suppose, and it will start from which value? V by k1. It will start from that point and the slope is negative. That means nature is drooping nature. मैंने समझ में आया?
सर,
हाँ, बोलो।
पहले स्टेप में सर वो और को कैसे लिखे हैं?
कौन सा?
लास्ट सेकंड स्टेप सर।
इस इक्वेशन से
यस सर, n इक्वल्स टू b by k1 minus ra by k1 into b by k1।
ये समझ में नहीं आया कैसे हुआ?
यस सर, वो स्टेप।
पहले पेज, प्रीवियस पेज को देखो। देखो क्या था? The speed equation is n is equal to v minus IRA by k phi. For shunt motor, we write the k phi is another constant k1. Can write v minus IRA by k1, and if we divided this equation as v by k1, and after that what we do? by k1 minus Ra by k1 into Ia. Manish, have you understand that?
Yes, sir.
Then we replace the value of Ia from the torque equation. Previously, what we do in torque equation, we know that from the torque equation for shunt motor, T is equal to K dash into Ia. So we can write Ia is equal to T by K dash. We replace, we have to replace the value of Ia in terms of T. So what we write actually? So if we replace, then we can write like that. We replace the value of Ia by T by K dash. So what we do next? This is the equation. From that we write V by K1 minus Ra by K2. The multiplication of K1 and K dash, we write K2. This is another constant, new constant, whose value is K1 into K dash. The final form of the speed equation is N is equal to V by K1 minus Ra by K2 into T. This is like a straight line equation. This is like a straight line equation. And if we plot that equation, suppose we are plotting in n in y-axis and torque in x-axis, then the nature of that, suppose this point is V by K1, and from that point the nature of the curve should be drooping. Manish,
Yes, sir.
अब समझ में आया?
हाँ, sir.
Okay. So this is the speed versus torque characteristics for shunt motor, and now we have to do the same thing for series motor. What we have to do is for series motor. For this is the diagram of series motor. For series motor, high proportional should be IAC, but in case of series motor, we know that for series motor, we know that IAC is equal to IA for series motor. So we can write I proportional to IA. So for series motor, what is the torque equation? Tell me, Manish, Khushbu,
K5IS tau
K
equals to
phi
K
IA. This
dash
is the
IA
general form.
square.
For series
K
motor,
phi IA square.
K dash IA square. K dash IA square. Because we replace the value of phi with a constant and IA. Because we replace the value of phi by IA into IA. So we can write from this equation we can write torque is equal to another constant K dash
K dash
into IA square.
IA square.
And what is the speed equation for series motor? N is equal to V minus IA RA by K phi. We neglect IA RA with respect to V for series motor. So we write V by K phi, and so we know that phi is proportional to armature current. So we write here K1 into IA. So we write this is by IA. So from this, what we write, N is proportional to 1 by IA, because the supply voltage is constant. Normally, what we do, we are making the supply voltage is constant. So we can write N is proportional to, sorry, you can say N is inversely proportional to the armature current. And if we replace the value, or we can write from here, N is equal to, suppose this is K2 by IA. If we replace the value from here, what is the value of IA from that equation? IA is equal to T by K dash under root over. From this equation we can write what is the value of IA? Khushbu?
Root under T by K dash.
K dash. If we replace the value of IA from the above equation, what we write? We can write N is equal to K2 by T under K dash. Suppose this is K3 by root under term. You can write that. Khushbu,
Yes, sir.
you can write like that.
Yes, sir.
Okay. Now we have to draw the characteristics. So what we get actually, n is equal to k3 to parameter t. Suppose this is t and this is n. Now tell me what is the nature?
Parabola.
Anyone?
Straight line.
Straight line. Why?
Y equals to mx.
Y is equal to mx. How can you say that this is y is equal to mx? Here t is,
K3, K3
if the equation is like n is equal to say k3 into t, then you can say this is like y is equal to mx. But the nature is not like that. So what should be the nature? Tell me. This is quite similar to inverse nature. Have you understand that? I have to explain how to do the how to graph plot the graph. Tell me. Suppose make a table. Suppose this is value of t and we have to put value of n. And the equation is suppose we are making a simple equation. Suppose this is like we are taking the value of k3 is 1. We are taking the value of k3 is 1 for sake of simplicity. Now let's take the value of t is 1. Then what is the value? Suppose Taking the value of T1 is 1. Then tell me what is the value. Zoom. Can you tell me what is the value of n at that time?
1 by root.
This is also 1. Suppose this is the point. We are taking 1 and 1, 2, 3, 4, 5, 6. Now after that, if the value of t is 2, what is the value of n at that time?
1 by root.
1 by root 2. What is the value calculated? Calculate it and tell me what is the value. Take 4, then take 9, 40. What is the value of n?
1.707.
1.707.
This is value of 1 by root 2.
What is the value of root 2?
1.46.
So if you divide 1 by 1.4, how much the value become?
0.707.
0.707.
707.
Suppose this point, and if you taking the value 4, then it becomes zero point 0.5, half. Then if you taking the value 9, then it becomes zero point 0.3. So the curve is like that. It is like that. And if you increase that value, then the curve is nature, and nature of the curve is like that. I hope you will understand this. Is it clear to you, Manish?
Yes, sir.
Okay. Now write the next topic is speed regulation. The next topic is speed regulation. Suppose we have a motor. Initially it is rotated with no load. Suppose we have a motor which is rotated at no load, and then we give it to full load, and the corresponding speed is nfl. This is no load speed, and this is full load speed. Suppose a motor initially rotated with no load, then we give it to full load. So n nl is the no load speed and nfl is the full load speed. The speed regulation is say defined as the change in speed from no load to full load. That means speed regulation is equal to no load speed to full load speed. But it is expressed as a fraction or percentage. If you say the per unit speed regulation, fraction means per unit speed regulation is equal to FL by full. And if you want to express it in percentage speed regulation, we have to do it in L minus NFL by NFL into 100%. Manish, have you understand that what is speed regulation or how to express the speed regulation? Khushbu,
Yes, sir.
the speed regulation is basically the speed difference between no load to full load, and it is basically expressed in per unit or in percentage. The per unit speed regulation is equal to no load speed minus full load speed by full load speed, and when it expressed in terms of percentage, then we have to multiply by 100. So that's all for today. Have you any question regarding this topic, today's topic? Manish, Khushbu, have you any question?
No, sir.
Yes, yes.
Now it's time for attendance. Yes,
Present, sir.
Khushbu,
Present, sir.
Manish,
Present, sir.
Rohit,
Yes, sir.
Sohel,
Yes, sir.
Praveen,
Present, sir.
Sumiran,
Present, sir.
Deepak,
Present, sir.
Muskan,
Present, sir.
Danish.
Present, sir.
Okay, you may leave now.